So I hope everything is fine, right? Today, as I told, I'll just deliver a lecture based on electrostatic potential, okay, or electric potential, we can say, right? This is really very simple topic, but very important topic, and you need to understand it, okay? You need to understand how to use those formulas because students knows the formula, right? Student know the formula, but they can't apply it properly, okay? Students know the formula but they can't apply. Why? Because they don't think about the condition, okay, when it will be valid, and how to apply this they don't know, okay? So that is what I'm going to discuss today, my dear friends. Just easy way, easy formulas, easy application, okay? Yeah, so let us start, my dear friends. We'll discuss today electrostatic potential, okay, or yeah, electric potential. Yeah. So at first, I would like to welcome you all. Welcome to Unacademy. Unacademy is the India's largest learning platform where you can prepare for the various competitive exams with the help of the top educators of the country with the quality content and great learning experience. So let's crack NEET UG. Yeah, so you can see here many charges are there, na? At center positive charge, and you can see there are electrons, right? Yeah. So there is a force. So simply speaking, let me introduce myself. My name is Rahul Dagariya. I have been teaching physics since 5 years in the various reputed institutions of India. Till now, I have mentored to the thousands of aspirants of NEET and IIT JEE, and now I am available here to help the students of the country to learn the concepts of physics for NEET UG with the best notes and best examples. If you did not download the Unacademy Learning app yet, please go to Play Store and type Unacademy Learning app and download it. Okay? Yeah. After that, the next thing I would like to talk about the Unacademy subscription. Actually, we have some new product for you, that is Iconic subscription. Okay, so before that, I need to discuss about this Plus subscription. So, what is a Plus subscription? My dear friends, you have already seen this many times, right? Plus subscription will give you the daily live classes, right? Just like special classes, you will get the daily live classes on an Academy app. Okay, you can chat with the educator, you can engage in any discussion, you can ask your doubts, and you can participate in the answer polls, right? So, simply speaking, everything will give you a lot of fun, right? So, you will have a lot of fun. Next, the live test and quizzes. My dear friends, any student can evaluate his performance by the regular mock tests and quizzes. Okay. Yeah. And without attempting the test, the students will definitely not know whether he is learning properly or not. Okay. How many concepts he prepared properly and how many concepts he cannot apply properly. Okay. So this is an important thing for all of the students, right? Next, structured courses, my dear friends. Structured courses means physics, chemistry, and biology. All three subjects you will get that too by the India's top educators, right? So you can choose your educator. This is the independence you will have on an Academy app, okay? Yeah. So next I will talk about the unlimited access. My dear friends, you know you can access to any live or recorded lecture unlimited times. Are you getting? So you can watch any live lecture, and you can watch the recorded lectures n number of times. There is no limit, okay? If you have an Academy subscription. So until your subscription is expiring, you can watch any lecture n number of times, okay? Unlimited access. And you can watch the India's top educators lecture. So let us talk about Iconic subscription. So you already know the benefits of Plus subscription. Now I am going to talk about the Iconic subscription. What is Iconic subscription? My dear friends, Unacademy will provide you a personal coach. Are you getting? Unacademy will provide you a personal coach who will monitor your performance time to time, okay, every day, right? Yeah, and he will give you the weekly reviews. Are you getting? Yeah. So simply speaking, a personal coach will guide you at each and every moment until you are going to give the exam, right? Yeah. And apart from that, at last, if your subscription is not expired, definitely they will guide you for counseling also. Yeah. So here we can talk about this personal coach, right? So get one-on-one guidance from the top exam expert of your personal coach to align your preparation strategy, right? So they will help you to prepare your preparation strategy. Okay. So this is the first thing, personal coach, very, very important thing, because each and every student need a mentor. Okay. Yeah. Next, test analysis. So, my dear friends, next I am talking about test analysis, whatever test you are giving. Okay. Yeah. So, your personal coach and Unacademy will provide you the in-depth analysis of the test. Are you getting? So that you can get to know properly whether you are learning properly or not. You are how many concepts you are good, and in how many concepts you are not that much good. Okay. So, this is the important thing. Next, I'll talk about the study planner. My dear friends, Unacademy will help you to make a study plan. Okay, after that, you can see it will ace your performance with a customized study plan and by weekly reviews. Uh, that highlight your progress. Okay, definitely if you don't know about your progress, okay, then how you will get to know that you need to prepare more, or it's okay, or you are on the right track or not, right? Yeah. So it's very very important. Study planner is very very important, right? Next, all benefits of plus subscription. So as you have seen in the last page, all benefits of plus subscription will also you'll get here. So simply speaking, let us compare this both. You can see on Plus subscription, you will get India's top educators, right? Interactive live sessions, you will get the structured courses and PDF, and you will get the live tests and quizzes. Okay, there's many things you are going to get on Plus subscription. But on Iconic subscription, you are getting all the Plus benefits, means India's top educators, okay, interactive live sessions, and after that, structured courses and PDF, and live test and quizzes. These are the things you are going to get on Iconic subscription and Plus subscription. But apart from that, on Iconic subscription, you'll get personal coach. Very, very important thing, personal coach. Study planner, expert guidelines, and test analysis. So these are the extra benefits you are getting, and definitely these are very, very important. And let's move to the next slide, right? So simply speaking, Iconic subscription. If you get the Iconic subscription, what you need to pay? It is available for 12 months and 24 months only. Are you getting? Yeah. So for 12 months, you need to pay 45,000 rupees, my dear friends. 45,000 rupees you need to pay for 12 months. And if you are giving exam in 2022, so definitely you should get the 24-month subscription, and you need to pay 61,000 rupees. Are you getting? So you will pay 61,000 rupees for 2 year subscription, right? Yeah. After that, I would like to say, if you are using my code Rahul T, RAHULT, if you are using my code, then you will get a 10% instant discount. Okay, and you are getting the 10% discount, and you need to pay only 40,500 rupees for 12 months course, and 54,900 rupees for 24 months course. Okay, so for 2021 students, 40,500 rupees, and for 2022 students, it is 54,900 rupees. Okay, yeah. So that's all. This was the Iconic subscription, and you already know the Unacademy subscription, right? What was that? 1 month, 3 months, 6 months, 12 months, and 24 months. These are the different packages available on Unacademy app. You can see 1 month fee is 6,000 rupees. But if you use my code RAHULD, you can see this code RAHULD. Then you need to pay only 5,400 rupees. If we see at 12 months subscription, you can see 12 month subscription is 30,000 rupees, right? Yes. So 30,000 rupees means it is equivalent to 5 month fee, right? It is equivalent to 5 month fee. And you need to pay how much? You need to pay 27,000 rupees if you use my code RAFULT. Okay. And you can see this 24-month subscription fee. So that is 36,000 rupees. It is equivalent to 6 months fee. Are you getting? It is just equivalent to 6 months fee. And you need to pay how much? 32,400 rupees. Are you getting just 32,400 rupees, means 10% discount you are getting if you use my code RAHULT. Okay. So simply speaking, this is really very, very cheaper than any other coaching institute, and you can prefer, right? Yeah. So that's all, my dear friends. Even you have joined any coaching institute, still you can join the Unacademy. You can get the Unacademy subscription. Okay. It is not costly. Yeah. So that's all, my dear friends. Let us talk about this. All plus benefits you are going to get on Unacademy app. So this we have already discussed, right? Yes. So you are getting top educators, mock tests, quizzes, structured batches, and the complete exam syllabus in line, right? Yeah. So let us discuss our today's topic, that is electrostatic potential. My dear friends, yesterday we could not complete this topic. Don't worry, we are going to discuss this topic today. Electrostatic potential. Okay. So I am saying this is really very very important topic. Okay. Yeah, definitely. This year you got question from the electric field. So yeah, force, है ना? Electric field, I guess. Yeah. So definitely next year you will get the question from electric potential. Okay. Very important topic. So let us talk about this. What is electric potential? Anyhow, I have written a formula there, but don't worry, I am explaining it. Okay. Let's say this is an electric field. Oh, I need to change the ink. Just a minute, my dear friends. Yeah. So I would like to say welcome you all, my dear friends. Okay. Pihu, Meghana, Karan, and yeah, so Himanshi, all of you are welcome here, right? This is a premier lecture. I cannot see who are there, but still, I am just welcoming all of my regular students and the new students. Okay, so my dear friends, I am always available here to help you. Okay, so let us talk about electrostatic potential. What is an electrostatic potential? So I am saying, let's say this is a region where the electric field is present. Okay, so in this region everywhere electric field is present, I am just considering. Okay, yeah, this is the point. This is called, let's say, infinity. What? Infinity. Okay, from here I am taking a unit positive charge. A unit positive charge I am taking, and I am bringing. Okay, so I will bring the unit positive charge from infinite to a point. So from infinite to a point in an electrostatic field, so I am bringing this charge here. This is what? Electric field. Okay, so this is some point P. I am bringing this charge from infinite to a point in electric field. Okay, yeah. So whatever work I did, I means what? I means external agent. So I will simply say work done by external agent in bringing a particle from infinite to a point P in an electric field. Okay. Yeah. What type of charge is brought? So that is unit charge. So work done per unit charge means work done divided by that unit charge Q. Okay. So this is called potential at point P. Okay. Remember, potential is always defined for a point. Are you getting? For a particular point? Doesn't matter whether there is any charge or not. Okay, it is simple thing. If there is an electric field, so definitely there will be a potential. And there will be a potential at each and every point. So simply speaking, you will say potential at any point can be given by work done in bringing a charge, work done by external agent in bringing a charge from infinite to a point in electric field without changing its kinetic energy. My dear friends, when you are bringing it, you need to bring it very slowly, without changing its kinetic energy. And then only the work done, right? That will be called work done per unit charge will be called potential of that point. Okay. Yes. Are you getting? So here, remember one thing. I told what? Ki work done by external agent and change in kinetic energy is zero. So how many forces are working there? है ना? How many forces are working there? First thing, I am the external agent. I am bringing the charge, so I am doing a work. Next, there is electric field. Are you getting? There is electric field. So electric field will also do the work. Are you getting? So electric field will do some work, right? Yes. So electric field did some work. I also did some work. So total work done by all forces, that is equal to change in kinetic energy. Are you getting? Work done by all forces is equal to change in kinetic energy. Okay. Who is doing work? Work done by external force plus work done by electric force. Are you getting? Work done by electric force means electric field, that will be equal to change in kinetic energy. So I told change in kinetic energy should be zero. What? Zero. So simply speaking, I can say what? Work done by external force can be written as negative of work done by electric force. Are you getting? Work done by negative of work done by electric force. Simply speaking, this is work energy theorem. What? Work energy theorem, work done by all forces is equals to change in kinetic energy. Okay, so work done by external force plus work done by electric force is equals to change in kinetic energy. That's all. So simply you are getting work done by external force can be written as negative of work done by electric force. Okay, so simply we can say potential at a point P is work done by external force in bringing a unit positive charge from infinite to point P in electric field. You know? Yeah, so per unit charge. So similarly, I can say Vp, you know, that will be equal to potential at P will be negative of work done by electric force. Are you getting? Negative of work done by electric force. Yeah, divide by Q. Okay, from where to where? Infinite to point P. So simply speaking, This is the same thing, but if you are taking work done by electric force, the electric field, you need to use negative sign. And when you are using work done by external force, then you need to use positive sign. So that's all. This is a simple definition of potential at a point. Okay. So simply speaking, work done by external force in bringing a particle from infinite to a point infinite to a point in electric field without changing its kinetic energy. Okay, that is called potential at that point. Another thing, another definition: negative of work done by negative of work done per unit charge by the electric field. Okay, and bringing a charge from infinite to a point in electric field without changing its kinetic energy. That's all. Okay, to remember this definition. Anyhow, this mathematical definition you remember, that's okay. Yeah, so let us read it. An electric field and electric potential due to some source charge at a point P is defined as the work done by external agent in taking a unit positive charge from a reference, means generally taken at infinite. Okay, and at infinite potential is always taken as 0. At infinite potential is always taken as 0. Yeah, to a point P without changing its kinetic energy. So simply speaking, you can say mathematically we can say V is equals to infinite to P by external force divided by Q, right? That will be equal to negative of work done by electric force. Okay, yeah, that's all. These are the basic things I have discussed with you. Okay, yeah. So this was electric potential, my dear friends. I spent that much time in the definition of electric potential because many times students get confused between electric potential and electric potential energy. Okay, so if you remember, this is potential, this is for per unit charge. Okay, and potential energy will be for a system of charge. Okay, yeah. Don't worry, I will discuss that. Let us talk about some basic properties of electric potential. So first property, potential is a scalar quantity. It is a scalar quantity. Okay. Why? Because work done per unit charge, work is a scalar quantity. Okay. Yeah. Potential can be positive, negative or zero. Obviously work can be positive, negative or zero. So potential can also be positive, negative or zero. Okay. Yeah. Potential is defined for a point. Next, SI unit of potential is volt. Generally, we use volt. You know, on any cell, you have seen 5 volt, 10 volt, 12 volt, you know, right? Yeah. So, potential unit of potential is always volt, and that is also called joule per coulomb. Okay. Some used to call it joule per coulomb. Whatever you say, I used to call it joule per coulomb. Okay. Yeah. So, how work done per unit charge? Unit of work is joule, right? Joule divided by coulomb, right? Yeah, so this is the unit. Okay, now let us write its dimension. How to write its dimension, you know? So its dimension can be given by m1 l2 t raised to minus 3 and a raised to minus 1. So this thing you need to remember. Okay, don't worry, I'll teach you units and dimensions so you will understand these things. Okay, so no need to worry about that. Okay, how I did listen. For work, you know what, force into displacement. What? Force into displacement. So m1 l2 t raised to minus 2. Okay, this is the work done. Divide by per coulomb. So per coulomb is what? Ampere. Are you getting? And yeah, so you know one thing, what? Q is equals to it. Q is equals to it means current into time. So amperes second. So you are getting m1 l2 e raised to minus 3 a raised to minus 1. So you got the dimensional formula of potential. Got it? That's all. So this is SI unit of potential and dimensional formula of potential. Yeah, so let's move to the next point. Okay, yeah. So the third point is the electric potential at any point is also equal to the negative of work done by the electric field in taking a charge. So I already told you, work done by external force divided by Q from infinite to P. You know? Yeah. And it also can be given by negative of work done by electric force. Electric force, okay, from infinite to P. Right. That's also same thing. So we have already done it. Point number 4, electric potential due to positive charge is always positive, due to negative charge is always negative. Remember, due to positive charge, potential is always positive. Due to negative charge, potential is always negative. Okay, yeah. So potential decreases in the direction of field. Remember, my dear friends, very, very important point. Potential always decreases in the direction of field. Listen, let's say I have a direction of field like this is the direction of electric field. Okay, electric field is constant, but in this direction I am having this point A, I am having this point B. So remember one thing, electric potential you know one thing, electric field at A is equal to electric field at B. It is given in the question. Magnitude is same, direction is same. But if you talk about potential, so potential of A will be greater than potential of B. Are you getting? Potential of A will be greater than potential of B. Why? Because you know, potential always decreases in the direction of field. Why? Because you know what, work done, work done by electric force. So in the direction of field, if you are moving the charge, then work done will be positive. Okay, work done by electric field is positive, and before that a negative sign is there. So you can see work done is negative overall. Sorry, potential is negative, right? So potential is negative. Okay, work done by electric field is positive, right? But work done, negative of work done by electric field is potential, right? So potential will be negative. Yani as you will go in this direction, potential will continuously decrease. Okay, that's all I wanted to explain. So potential of A will be greater than B. Yeah. Next, potential is a scalar quantity, so definitely we can use like this. Let's say I have some, let's say 1, 2, 3, 4, 5, 6, like that system of particles I am having, and this is some point P. So at point P, I will say the potential due to all will be added, V1 plus V2 plus V3 plus V4, like that, Vn. So simply speaking, if charge is positive, I will write potential positive. Charge is negative, I will write charge potential negative. Okay, simply you will add it algebraically. That's all. So now let us discuss some basic questions, my dear friends. Okay, so I am coming back to the questions. So a charge of 5 microcoulomb is taken from infinite to a point in an electric field. Okay, so infinite to a point in an electric field, simple thing. So Q is equals to 5 microcoulomb, first data. Next, without changing its velocity. So are you getting, without changing its kinetic energy means at that point we will talk about potential. If work done against the electric field. So it is given that work done against the electric field. Yeah, so I can say negative of work done by electric field. Now, if work done by electric field, then I will say directly W electric. But it is against. Against means it should be negative, right? Yeah, that is minus 80 microjoule. That is minus 80 microjoule. Okay. Yeah. Find the potential at that point. So you need to find the potential at that point. So potential at that point P can be given by negative of work done by electric field divided by charge. Okay, put the values, get the answer. So answer is minus 80 microjoule divided by 5 microcoulomb. Okay, so you are getting the answer minus 16. You are getting the answer minus 16 volt. Okay, that's all. This is the answer. Here it is written work done against electrostatic force. It means what? Negative of work done by electric force. Okay, that's all. Okay. So let's move to the next slide. Now I'll talk about this. Question number 2. When the charge of 10 microcoulomb is shifted from infinite to a point in electric field, from infinite to a point. So charge you are getting Q1 is 10 microcoulomb. Okay. Yeah, it is found that the work done by electrostatic force is minus 10 microjoules. So work done by electrostatic. Are you getting? So work done by electrostatic is minus 10 microjoule. Sorry. Yeah. So here work done by is given. In last question, work done against was given. Okay. Yeah. If charge is double, then taken against from infinite to the same point. Okay. Yeah. Again. Huh. So then find the amount of work done. Okay, so simple thing, right? Yeah. So let us do it. So simply I will say potential at any point P can be given by negative of work done by electric force divided by charge. Okay. So I will directly find it. So I will get minus 10 microjoule divided by minus work done by electric force is minus 10. है ना? So negative of work done by electric force is minus of minus 10. Are you getting? Minus of minus 10 microjoule. Okay, divide by Q. Right? So what you are getting? So directly you are getting minus minus plus, and value of Q is also 10 microcoulomb. So it will be cancelled. You will get 1 volt. You are getting 1 volt. So you got one thing. Potential at point is 1 volt. Okay. I think you might get confused. So once again, I am telling, listen. In question, it is told that work done by electric. So work done by electric is minus 10 microjoule. Okay. So what will be the negative of work done by electric? So that will be equal to minus minus plus 10 microjoule. Okay. So that only I have used negative of work done by electric force per unit charge. Okay. That's all. So I got 1 volt. I got the potential of point P. Now in the next part, we need to find instead of 10 microcoulomb, if I will bring the 20 microcoulomb from infinite to that point, how much work I need to do. So simply speaking, Vp is equals to negative of work done by electrostatic force divided by charge Q. है ना? Yeah. So I can say W is equals to minus of W by what? W by electric force. Okay. W by electric field, we can say that is minus of Vp into Q, minus of Vp into Q2. Okay. Yeah. So minus is there. Okay. What is the value of Vp? So that is 1 volt. So I have written 1 volt, and value of that is double, right? So that is 20 microcoulomb. 20 microcoulomb. So answer is minus 20. Answer is minus 20 microjoule. That's all. This is the answer. So the work done by the electric field is minus 20 microjoule. That's all. This is the answer, my dear friends. Okay. Got it? What we did from the first part, we got the potential of a point, right? And in the second part, using that potential, we need to find the work done in bringing the different charge. That's all. So very simple. All of you can solve it, right? All of you can solve it. Okay. Yeah. So they ask what work done by electric field. So answer is minus 20 microjoule. If they ask work done against the work done against electric field, so answer will be plus 20 microjoule. Okay. Work done by electric field, that is minus 20 microjoule. Work done against electric field, that is plus 20 microjoule. That's all. Okay. I hope you are getting it. Okay. Yes. So, my dear, simple thing, right? Let's move to the next. My dear friends, potential due to a point charge. So, let us discuss some basic formulas. Okay. Potential due to a point charge. So, let's say I have a point charge. This is the point charge Q. Okay. And here I am writing that is distance B, and here a point P. At this point P, I need to find what? I need to find potential. So, how you will do? Listen. Simply speaking, infinite to here you are bringing. So, I will say W. Listen, work done is F dot dr, integration of F dot dr. Okay, if you are writing this is external force, so you can write integration of F electric. Okay, and you need to use here a negative sign. Dot dr. Dr means what? A small displacement. Don't worry, you don't need to remember this derivation. You just need to remember the final formula. Okay, yeah. So from where to where? So from infinite to point P. Okay, yeah, infinite to R, you can say. Okay, so how you will do? So you know potential at point P can be given by work done per unit charge. Okay, work done per unit charge. Okay, so directly how you will write? Let's say yeah, this is some point charge is capital Q. Okay, so work done per unit charge, this charge is called some test charge. Okay, and this charge due to a point charge Q, so this is called source charge. Capital Q is source charge, small q is some test charge. Okay, yeah, so here I am writing minus of integration of W upon Q. So you can say F upon Q, F electric upon Q dr, and you know F by Q is called electric field, so minus of E dot dr. So remember this result, my dear friends. V is equals to integration of minus of integration of E dot dr, minus of integration of E dot dr. This formula you need to remember. Okay, so this formula if you remember, you can solve any question. Okay, yeah, so I have just derived this formula, so you need to remember this. Okay, V is equals to minus of E dot dr, or you can also say like this: E is equals to minus of dv by dr. Are you getting? If electric field is given, so you can write E is equals to minus of dv by dr. Okay, differentiation of potential with respect to distance or position, you can say. Yeah. So let us derive that formula. Potential at point P can be given by minus of E dot dr. Okay, let us solve it. Let us solve it. So negative sign is there. Okay, and this is infinite to R. So you know formula KQ divided by R square. You all know the formula KQ divided by R square. Okay, and here you will use dr. If you integrate it infinite to R, so what you are going to get? So you are getting KQ divided by R. What you are getting? KQ divided by R, and from where to where? From infinite to R. Okay, so from infinite to R you are getting. Okay, so directly you will write what? Vp is equals to KQ divided by R minus directly you will get here what? Directly you will get here 1 by infinite is 0. So answer is V is equals to KQ by R. So this is the formula you need to remember. Okay, my dear friends, that's all. So very simple formula. You don't need to remember that much. You just need to remember two things. V is equals to minus of E dot dr. First thing, you remember this relation. Okay. Second relation, you remember E is equals to minus of dv by dr. Okay. And third thing you need to remember, due to a point charge, potential at any point is kq divided by r. Okay. And this q is that point charge. Q is that point charge. Okay. Yeah. So that's all, my dear friends. This is the potential at any point due to a point charge. Remember this formula. Next, there are four charges. They are placed at the vertices of the square. Okay. And let's say side of this square is L, length of the side is L. Okay. Yeah, these are the charges. You need to find, calculate the potential at the center of the square. So you need to find potential at the center of square. I'm giving you four options: A, B, C, D. Okay. Yeah, so first option is KQ, root 2 KQ divided by L. Next, root 2 KQ, this is negative, divided by L, minus 4 root 2 KQ divided by L, and last option is 0. Which of the following is the correct answer? Okay. Yeah. So simply speaking, my dear friends, you can solve it fast, 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 fast. I'm giving you 1 minute. You can do it. Okay. Try this fast. Anyhow, I'm going to explain you. You can try. Right. So it's a really very, very simple question and all of you can solve it. Right. Yes. So my dear friends, yes. So let us talk about this. I'm solving this. Answer is 0, I guess. Okay. So let us solve it. So my dear friends, simply speaking, I will say at C, potential I need to find at C. You know what is the length of the diagonal? Diagonal is always having length L root, root to L. Okay. If you talk about half of the diagonal, so this length from here to here will be L by root 2. Okay. Root 2 L divided by 2 is L by root 2. Okay. So I'm using that only. So I will say due to first charge, due to second charge, due to third charge, and due to fourth charge, due to all I will add. Okay. Yeah. So all charges should be placed with sign. All charges should be placed with sign. Okay. So let us find it. So I am going to find it. I am saying first charge is plus q. So that is kq divided by L by root 2 first, right? Next, V2. V2 is minus 3q. So minus 3kq divided by L by root 2. Okay. Third is plus 4q. So 4kq divided by L by root 2. Okay. Yeah. And the last, that is minus 2q. So minus 2kq divided by L by root 2. Okay. Yes. So let us simplify it. What you will get? So root 2 kq by L is common for all. And here 1 minus 3 plus 4 minus 2. Are you getting? So you can say 4 plus 1, 5, 3, 2, 5. So 5 minus 5, 0. Answer is 0. So 0 volt is the potential at the center. So got it, right? That's all. So this is a simple answer. I hope all of you get it, right? So simply speaking, potential at any point is sum of potentials due to all points at that point. Okay, yeah, right? Simple algebraic sum. So my dear friends, let's move to the next slide. Question number 4. So I am going to talk about question number 4. 2 point charges 2 microcoulomb and minus 4 microcoulomb are situated at points minus 2 comma 0 and 2 comma 0. So these are the 2 points are given to minus 2 comma 0 and 2 comma 0 respectively. Find out the potential C. Find out the potential C for so potential at point C and D. So there are 2 points C and D. There you need to find the potential. So you can see this is point A. Its coordinate is minus 2 comma 0. Okay. Now I'll talk about this is the origin and here is point B. So B is having the coordinate 2 comma 0. What is the distance between A and B? That is 4. Are you getting? That is 4 meter. Okay. Now here is point C. So here is point C. C is having coordinate 4 comma 0. So what is the distance between B and C? That is 2 meter. Okay. 2 meter. Okay. So let us find the potential at point P. Point C. है ना? I am giving you 4 options. Choose the correct answer. A minus 6,000 volt. B minus 15,000 volt. Minus 15,000 volt. C minus 3,000 volt. And D minus of 5,000 volt. Which of the following answer is the correct? Yeah. So you need to choose the correct answer, my dear friends. You need to find the potential at point C. Okay. Yeah. So very simple. Anyhow, I have given the hint. Charge placed at A point is 2 microcoulomb and charge placed at B is minus 4 microcoulomb. Okay, so as per my data, answer should be minus 15,000 volt. Okay, so I'm going to discuss this. Listen, how to do it. Okay, how to do it. So simply due to individual charge, we'll find potential at that point. Simple, you know. So let us find potential at that point. So VC will be equal to V uh, due to A and V due to B. So directly I am writing due to A on C plus V due to B on C. Okay, so I'm writing the values. So that is K, and K means what? I'm writing the proper value. So you know V is equals to K Q divided by R due to a point charge. So I'm using this value. So K is 9 into 10 raised to 9. Okay, Q is 2 into 10 raised to minus 6. Okay, so K Q divided by R. R is for this 4 plus 2, 6 meter. So I am writing here 6. So K Q by R I have written. This is due to A, है ना, on C plus अब यहाँ on B it is negative charge, so I will write negative sign KQ by R, so 9 into 10 raised to 9. Q is minus 4 microcoulomb, so this is 4 into 10 raised to minus 6. Minus I have already written here. Okay, divide by divide by what? Divide by, you need to write the distance between B and C, so that is just 2 meters. What? 2 meters. Okay, finally what you are going to get here, so let us cancel this. This is 3 times, this is 2 times, 2 cancel. Okay, this will be cancelled 2 times. So directly you are getting 3 into 10 raised to 3. 3000 minus 9 into 2, 18,000. So 3000 minus 18,000 volt. Directly you are getting minus of 15,000 volt. So this is the answer for point C. So potential at point C you are getting minus of 15,000 volt, right? All of you remember the value of K. You remember the formula V is equals to KQ by R. That's all, my dear friends. So this is a very simple thing, and all of you need to remember. That's all. So this is a very simple thing, right? Let us talk about the potential at point B. So I am giving you 4 options. Okay, I'm erasing this. I'm erasing this. I hope all of you got it right. If you did not get, please go back and watch it again. Definitely will get, okay, because I explained it in a simplest way. So let us talk about potential at point D. So next we need to talk about potential at point D. How to find that? So you know this is point A, this is point B. Okay, it is having minus 2 comma 0. Here is, let's say, origin, and this is 2 comma 0. Okay, and point D is having coordinate 0 comma minus root sorry 0 comma root 5. Okay, means it is on the y-axis. So this is on the y-axis. So I am taking here this point 0 comma root 5. Okay, means this length is root 5, this length is 2, this length is also 2. Okay, yeah. So how to find potential? So for potential we need to take this distance, this is R, and for this we need to take this distance, this is R. Okay, yeah. So finally what is the value of R? So R will be equal to root of perpendicular square plus base square. So directly you will say what? Root of what? Root 5, root 5 square plus 2 square. So root 5 square plus 2 square means 5 plus 4 9, root 9 is 3. So value of R is 3, value of R is 3. Now I'll write potential at point D. So that is potential due to A on D plus potential due to B on D. Okay, so let us solve it. Potential due to A on D is KQ divided by R. So 9 into 10 raised to 9 into 2 into 10 raised to minus 6, because it is microcoulomb, divided by R. R is 3 meter. Okay, minus 9 into 10 raised to 9 into, this is 4, so 4 into 10 raised to minus 6, divide by, this distance is also 3. So if you will solve it, what you will get? 3 into 2 6, and here you are getting 3 into 4 12. So 6 minus 12 is minus 6. So minus 6,000. Answer is minus of 6,000 volt. That's all. This is the answer. This is the answer for this question. So minus 6,000 volt is the answer. Okay, that's all I wanted to explain you, my dear friends. Okay, so simply speaking, all of you can do it. I know, very simple topic, very simple formulas. So this is all about the electric potential due to a pointed charge. Okay, right? I hope you are getting it right. So electric potential due to a point charge we have discussed. Now we'll talk about the electric potential due to some other. Okay, yes. So my dear friends, don't worry about that. We'll discuss very fast. Okay, yes. So, my dear friends, I am going to talk about this question number 5. A rod of length L is uniformly charged. A rod of length L is uniformly charged, okay, and with charge Q. So, charge is Q. Calculate the potential at point P. है ना? Yeah. So, there is a rod. Let's say this is a rod and it is having charge Q, total charge Q, and its length is L. Okay. And let's say there is a point R at a distance R from this. So, this is the distance R, this length is L. Okay, you need to find the electric potential at point P. Yeah, so really this is very good question, and you need to remember its formula. If you can't remember the formula, just learn how to do it. Okay, so simply speaking, charge is distributed throughout the length. Throughout the length, the charge is distributed. Okay, yeah, whenever this type of question comes, this is a uniform mass distribution, है ना? Continuous mass distribution. If continuous mass distribution is there, you cannot use the formula of point charge. Are you getting? Are you getting? So you cannot use the formula of potential due to point charge. Means KQ by R you cannot use. Okay. Then how can I find this? How can I find this? What I need to do? So simply speaking, my dear friend, make the point charges of this rod, make the point charges of this rod, so that that formula will be applicable. So for that, what I will do is i'll just consider I'll just consider a small segment. So I have just considered a very small segment which can act as a point charge. Are you getting? Because AQ divided by R is applicable only for the point charge. So I am saying, let's say length of this small segment is dx and charge on this small segment is dq. Are you getting? Charge on this small segment is dq and it is at a distance x from point P. So total distance of this point, uh, of this segment from the point is x. Okay, now we can use the formula because this dq charge is a point charge now. Okay, so let us use this. So I know I can say due to this point charge the potential is dq. Okay, sorry, potential is dv. So dv is equals to kq by r, means k dq divided by x. Okay, yeah, this thing all of you got, right? This much all of you got. But how to find the value of dq? You know, so you know one thing, L length of the rod is having charge q. So one length of the charge will have q by L. है ना? Q by L charge is the charge on the unit length. Then the small length dx length will have charge dq, and that dq can be given by charge per unit length q by L into dx. Are you getting? Right, all of you have studied this type of method in 10th class, 9th class, 8th class, right? So simply speaking, L length is having charge q, so one length will have charge q by L, है ना? Yeah, next dx length will have charge one length into dx, charge per unit length into dx. Okay, so it can also be written like this, lambda dot dx. Lambda is charge per unit length. Okay, yeah, so let us talk about this. You can write here k is there, q is there, by L is there, x is there, and dx is there. Okay, so this is the value of dv. You need to find the value of v, potential. So v will be equal to integration of dv. That can be written as integration of kq divided by lx dx. Integration from where to where? So you can see the x is varying. This x is varying from r to L plus r. R to L plus r. Are you getting? One end is at distance r, another end is at distance L plus r. So r to L plus r. Okay. Yeah. So if I will calculate it, what I will get? KQ divided by L is constant, and 1 by x I will get ln x. What? Ln x. Let us put the value. So you'll get what? If you put the value, finally formula you'll get, I'm writing here in this section. Okay, so v at point P will be equal to kq divided by L. Okay, here you will write, I'm just writing in multiplication. I need to erase this, just a minute. I need to erase something so that we can draw properly. Okay, yeah, so listen what I can write. KQ by L. Here you will get log. Ln means log. Okay. L plus R divided by R. That's all. This is the answer. Okay. So that's all. Very simple. I hope all of you got it right. I hope all of you got it. If you did not understand, once again I am explaining, right. So you have to choose a small segment. Why you need to choose a small segment? Because you can apply the formula only for the point charge. KQ by R is applicable only for the point charge. So directly we'll say dV is equals to K dq divided by x. Okay, yeah, now you need to find the value of dq. So you will say L length is having charge q, and now one length will have charge q by L. Why? Let's say mass of 10 meter is 5 kg. So mass of 1 meter will be how much? Half kg, है ना? So like that only. So my mass dx length will have charge dq, and dq is equals to q by l into dx. Charge per unit length into small length. Okay? Yes. So directly you will write here v is equals to integration of dv. So here you will write integration of k q by l x dx. Okay? Limits will be from where to where? So from r to l plus r. है ना? One end is at distance r, another end is at distance l plus r. So directly you will get kq by l is there log x, okay, and limits from r to l plus r. Put the limit, upper limit minus lower limit. So you'll get kq by l ln l plus r minus ln r, right? You are getting like this. And all of you know the properties of log. Log a minus log b can be written as log a by b, okay? So this is the basic property of log you need to remember. So directly you will get kq by l ln l plus r divided by r. So this is the formula we have derived. If you remember the formula, then okay. If you remember the method, then also okay. Okay, very, very simple thing. That's all, my dear friends. So let us talk about the next slide. Next. Yeah. So very, very important, potential due to a ring. My dear friends, very simple. Let's say this is a ring you can see in the diagram. You can see in the diagram, there is a small segment chosen, right? So what we'll do, this entire ring will have charge q. Entire ring will have charge q. Okay. So let's say this is a small segment having charge dq. So due to this dq charge, what will be the potential at the center? The potential at the center, what will be that? So I am going to write potential at the center, okay. At center I am writing dv. Dv will be equal to k dq. K dq divided by r. Are you getting? R is constant here, radius, right? Okay, so you need to find v. So what you will do, integration of k dq divided by r. R is constant, k is constant, integration of dq is q. So directly you are getting kq divided by r. That's all. So you are getting, right, key all the segments or entire ring is having, you know, all points on the ring are having the same distance from the center. So directly we'll add all of this kq divided by r. Okay, right? So that's all. Finally you are getting due to the ring at the center, potential will be kq by r. Very simple, right? Okay, next is the uniformly charged ring, potential at the center. Huh. So non-uniformly, if it is non-uniform, are you getting? Let's say charge distribution is more here and charge distribution is very less here. So what will happen in that situation? I am saying total charge is q. Okay, total charge is q. So still I'll say the distance of entire charge is same. So integration of k dq by r. So answer will be again k total charge divided by r. So very, very simple formula, kq by r. You need to remember. For any ring, potential at the center is kq divided by r. That's all. Remember, okay? Now, the potential due to the half ring at the center. So let's say there is a half ring. It is not a complete ring. It is just a half ring or semi ring, right? Right? Yeah. So due to this half ring, you need to find the potential at the center. So you can see this is the ring. This is a point. So this point is at distance r. This point is at distance r. All points are at distance r only. And charge on this is, let's say, q. So again, formula will be k q divided by r. Doesn't matter what is the length of this arc. Simply speaking, this is just a ring, okay, and all the points on the ring are having same distance from the center. So whatever charge is there, k total charge divided by r. That's all. This is the answer. Okay, I hope all of you got it right. Next, I will talk about the potential at the axis. Very, very important. You can see the diagram. You can see the diagram. A ring is there having radius r. Ring is there having radius r. Okay. So simply speaking, this is a ring having radius r. On its axis, are you getting? This is a ring, and on this axis, so this pen is called axis. Are you getting? So at this point, we are finding the potential. Okay, yeah. So what will be that at point? So I am saying from the center, the point P is at distance x. Point P is at a distance x, and radius of this ring is capital R. Okay. So what is the distance of circumference? What is the distance of circumference point from point P? So that we need to find. So using Pythagoras theorem, we'll get, right? Using Pythagoras theorem, we'll get. So how to do it? So you can write this ring. This is point center. This is point P. This distance is x and this distance is capital R. Okay. So I will say this will make a right angle triangle, and this distance R will be equal to what? Root of perpendicular square plus base square. So r square plus x square. So all of you know this distance, and you can see each and every point will have same distance. Each and every point on the ring will have same distance, constant distance from point P, right? Yes. So that's all you need to remember. The potential at the axis of the ring, directly you are getting V is equals to integration of dV. So directly you will get KQ divided by root of r square plus x square. Okay, because the formula is simple. KQ divided by the distance r. You know? So you are directly getting KQ divided by root of r square plus x square. So remember this formula: potential due to a ring at a point P on the axis of the ring. Okay, x is what? Distance from the center. Right. So that's all. This is very simple formula. I hope all of you are getting it right. So very nice. All of you got it, got this formula. So please remember, all of you can do it right. Yes. So my dear friends, let's move forward. Let's move forward. So we'll discuss further. Now questions are there in front of you. Find the potential at the centers of the ring. So my dear friends, I am talking about the potential at the center of the ring. So at first I will take point A. Point A, है ना? Point A, I will say there is a ring. So because of this ring 1, this is let's say ring 1, and here is ring number 2. So there are two rings, okay? Yeah. So simply speaking, its radius is 2r. This distance is given r, and this is also r. Okay, at point A we need to find. So I will say potential at A will be equal to potential due to first ring plus potential due to second ring. Okay, so due to first ring means at the center, so that will be K. Its charge is Q divided by R. Okay, due to second ring you need to find, so charge is minus. Are you getting? So I will say K, for the second ring the point will be on the axis. So which formula? B at any point on the axis can be given by KQ divided by root of r square plus x square, right? So I'm using this. So I'm using this. Charge is minus root 5q, so I'll use that. K, and this is root 5q. K into root 5q, minus sign I have already used. Okay, divide by root of r square plus x square. What is the radius of this? So its radius is 2r. So I will write root of 2r square, and value of x is just r. So I'll write r square. Okay. So finally what I am getting, KQ divided by r, I am taking common. Okay. Here I'll get 1 minus root 5 divided by root 5. So this is 1 minus 1. We are getting 0. What we are getting? 0. So simply speaking, potential at the center of the first ring at point A we can say. So that is 0. Okay. Simply we have just used the formulas, nothing else. Potential due to first ring means at the center. Next, potential due to second ring means at a point on the axis. Okay. That's all. So finally you'll get the answer. So answer is 0 for this point A. Huh? So I hope all of you got it right. Next, potential at point B we need to find. So I will say V1 plus V2. Okay. So at point B means this is a big ring. At its center we need to find, and this is small ring. It is here. So for small ring it will be on the axis, and for big ring it will be on the center. This R, and this is also R. Okay. So let us do it. So simply speaking, for this V will be equal to what? For the ring itself. So that will be K. Its charge is minus root 5Q. Are you getting? Sorry, due to ring number 1 we need to write first. You know? So I am writing due to ring number 1 first. Okay, so just a minute. Yes. So let us write it. So I am talking about the potential due to the small ring first. Potential due to small ring at point B. So simply speaking, this is the small ring and this is point B. So this distance will be how much? This is R, this is R. So this will be root 2R. You know? Root of R square plus R square, root 2R. Okay. Yeah. So finally you are getting KQ divided by root 2R. Okay. Here you will get minus K into root 5Q divide by its distance means its center, right, at its center. So directly you'll write 2r. Okay, so that's all. So let us simplify it. What you are going to get, KQ divided by r is taken as common, and here I am going to take the LCM. So if I'll take the LCM, I'll get 2 here. 2 here means here you'll get root 2 minus root 5. That's all. Answer over. So finally, you are getting potential at point B is KQ by R, है ना? And root 2 minus root 5 divided by 2. That's all. So very simple, है ना? So this is the very simple question. All of you can solve it, right? Sorry. That's all. Okay. So these are the 6 questions we have solved. Let's move further. I hope all of you are understanding it. All of you are getting it, right? So my dear friends, very, very simple. Potential due to first ring at its on center, and then potential due to second ring. So this point will be for its, at its axis, right? So simple. So both the formulas are used in this question. Okay. Yes. So you can see this type of question can be solved within 1 minute, right? If you remember the formula. So definitely formulas are important. You need to remember. Make a formula chart and keep it on your table. Make a formula chart and keep it on your table. Very essential. Potential due to a uniformly charged disk. Now I'll talk about a uniformly charged disk so that you just remember a formula, nothing else. You just remember a formula. So let's say you have a disk. So this is the disk, okay, and disk will have the charge distribution throughout its area like this. So I'm saying, let's say charge density is sigma. Charge density is sigma, okay. So charge density I have written sigma, and this is its center. Its radius is r. So I'm saying, let's say any point at distance x from the center, right? So this is point P. So I will say potential at point P can be given by sigma upon 2 epsilon naught root of r square plus x square minus x. Please remember this formula. Very, very important. You don't have any other option. You don't have any other option. You need to remember this formula at any cost. Okay. Yeah. What will be the potential at the center? What will be the potential at the center of the disk? So sigma upon 2 epsilon naught is okay. But the value of x is 0. Why? Because at the center means value of x is 0. So directly you'll get what? Root of r square. So directly you'll get sigma r upon 2 epsilon naught. So this is the value. This is the value of potential at the center of the disk. Okay. Sigma r upon 2 epsilon naught. Okay. So that's all I wanted to say, my dear friends. You need to remember. Okay. Yeah. So if instead of sigma there charge q is given, so how you will find? All of you know sigma is called charge divided by area. What? Charge divided by area. Why area? Because this is a disk. Okay. If it is a sphere, then we'll write volume, but this is a disk, so we'll write sigma is equals to charge divided by area. Okay. So charge is so charge is equals to sigma into area. Are you getting sigma into area? Or area of disk is pi r square, right? Because this is a circle, so sigma into pi r square. So you can use this formula and you can find the this in form of what? In form of chart, right? So these are the formulas you need to remember. Okay. So I am writing potential as a function of charge. So you can write what? Q into sigma is equals to q upon pi r square, right? So 2 epsilon naught pi r square. Okay. Root of r square plus x square minus x. Okay, so now put the values. So how you can write the values? So simply speaking, 1 upon 4 pi epsilon naught is k. So you can write 2kq upon r square. Are you getting? 2 I have multiplied here and here. So directly you can say 1 upon 4 pi epsilon naught is what? That is k. So 2kq upon r square. Okay. And here you are getting root of r square plus x square minus x. That's all. This is the formula, right? In terms of chart. That's all. How the curve will look like? What will be the curve? So let us talk about some basic curves. Listen, how the curves will look like. Okay. So at first I am going to talk about this. So you all know P is equals to KQ by R. P is equals to KQ by R. So the curve will be like this. V and this is R, and there is inverse relation. Whenever there is an inverse relation, the curve will be rectangular hyperbola. So the curve will look like this. It will come from infinity and it will move like this. Okay. So this is just a rectangular hyperbola. So the curve will look like this. Okay. That's all. So this is the curve between potential and R. Okay. Yes. So if proper way, if you draw, it will look like this. Okay. V and R. So that's all. The curve will be like this. Next I'll talk about this. Yeah, due to ring, remember the curve will look like this. This is a ring. I'm saying this direction and this direction point can be anywhere. So I'm writing this is the potential V, and this direction, this direction. Yeah. So I'm drawing in any direction, potential will be positive only because charge is positive. So it will look like this. Are you getting? So maximum potential will be at the center. maximum potential will be at the center. So this type of curve you will get. Okay, this type of curve you are going to get for the potential. Okay, so remember this. Okay, due to a ring. Next, semi-ring we don't need to find. Okay, yeah. Next, directly we'll talk about potential due to uniformly disk. So the curve will look like this. Okay, at the center it is sigma r upon 2 epsilon naught. At the center it is sigma r upon 2 epsilon naught. Okay, so that's all. This is the potential at the center, that will be maximum sigma r upon 2 epsilon naught. Okay, and it will decrease with the distance, right? So that's all. So this is the potential due to a disk. Okay. Next, I will talk about potential due to a uniformly charged sphere. My dear friends, very very important. Don't forget the spheres. Spheres are the main interest of NEET exam. Okay. So simply speaking, I am going to talk about the potential due to a uniformly charged spherical shell. Okay. So this is a shell. So we know one thing. Outside, we out. We will just consider this entire shell is a point charge placed at the center. So directly you'll say KQ divided by R, where for all values of R greater than equal to R. Are you getting? Yeah. At surface, I will write KQ divided by capital R. Okay, because small r is equal to capital R. Okay. Next, V inside. You know one thing, V inside. All of we know, if electric field inside is zero, then inside the shell at any point, if you move the charge, then work done will be zero. But if we bring the charge from infinite to surface, then the work done will be there. So I will say what? At any point inside is work done in bringing from infinite to surface plus work done in bringing from surface to any point inside. Okay, so we will add this both, right? We will add this both. So we know one thing, the first will get KQ divided by R. Okay, and second, inside the shell, if you will move that charge, you will get zero only. So final answer is KQ divided by R. Means whatever the potential is at the surface of the uniformly charged shell, the same potential will be at any point inside the shell, even at the center also. Okay, so this is the formula you need to remember. Okay, yeah. So remember this thing, very very important, right? These formulas you need to remember. First thing, at point outside, that is KQ divided by R. At point inside, so that is KQ divided by capital R. At surface, that is KQ divided by capital R. Okay. So remember, V in electric potential inside is electric potential from at the surface, we can say at the surface means the charge is brought from infinite to point P, means at the surface, so infinite to R, plus potential due to the charge brought from surface to inside is zero. So I will say, if from surface to inside, if you will bring the chart, there will be the work zero. Why? Because inside the shell, electric field is zero. If electric field is zero, work done will be zero. So definitely this quantity will be zero. So answer V in will be equal to V surface, and that is KQ divided by R only. So you just need to remember the formula. Okay, yeah, that's all. Okay, so let's move to the next slide. My dear friends, still I told what? I told what? If you are bringing the infinite to surface, you need to do the work. Means potential will be there. That is V surface, KQ divided by R. But inside field is zero. Whenever electric field is zero, work done zero. So inside the shell, if you take from here to here, let's say this is a shell, and inside the shell, this is point A, this is point B. If you move a charge Q from this point to this point, the work done will be zero. Are you getting any change in potential between A and B? That will be zero only. Okay, that's all. Change in potential is zero, but point A and point B will have same potential. That is KQ divided by R. Okay. Yes. So I hope you got it. Let's move about yes. This is the last topic for today's class. Anyhow, potential due to a uniformly charged solid sphere. So now, my dear friends, I am going to talk about potential due to a uniformly charged solid sphere. Okay. So I am having, let's say, a solid sphere. Okay. Due to a solid sphere will have the charge distributed throughout the volume. Okay, so charge distribution will be throughout the volume. In a shell, charge will be only at the surface. Okay, yeah, its radius is, let's say, capital R. Okay, so at first I'll talk about outside. So for outside point, for any point outside, you know, yeah, so for any point outside, we will say what? Potential is KQ divided by small r. Why? We'll consider this entire sphere is a point charge placed at the surface of the sphere. Sorry, placed at the center of the sphere. Okay. Yeah. So simply speaking, I will just consider this entire sphere is a point charge and placed at the center of the sphere. So we'll treat like that and we'll get kq divided by r. Why? Its derivation, if we'll do using integration and all, you'll get this formula only. Okay. Next. Yeah. So next I'll talk about the potential inside the shell. Inside the shell, if you want to talk. Okay. Inside the shell, if you want to talk, then you need to remember the formula. Yeah. V in. You know one thing? This is a sphere. So here is charge. Entire is having charge. Are you getting? So if you are bringing from infinite to surface, you need to do some work. And inside also there is a charge. Means if you bring from here to here, again you need to do some work. Are you getting? So you need to work in two segments from infinite to r plus v from r to small r. In both the situation, there is some work, both are non-zero. So finally, the formula you need to remember, my dear. Don't go for this, just remember the formula. What will be the formula? 3kq divided by, sorry, kq divided by 2r cube, 3r square minus r square. Are you getting? Capital R is the radius of the sphere and small r is the radius. Sorry, small r is the distance from the center. Okay. Yes. So simply speaking, this formula you need to remember. Okay. For any point inside the solid sphere, kq divided by 2r cube, 3r square minus r square. Remember this formula. This is for outside. This is for inside. Okay. Yeah. What will be at the center? So for center, you will write small r is equals to 0. Okay. Small r 0 means you are getting 3kq divided by 2r cube. Remember this formula. 3kq divided by 2r cube. Okay. So these are just the basic formulas you need to remember. Okay. You don't have any other option, right? So 3kq divided by 2r cube, you remember this formula. Okay. In terms of charge density also we can find these formulas. In terms of charge densities you can find the formulas. Just put q is equals to rho divided by volume. Rho divided by 4 by 3 pi r cube, you'll get this. Rho upon 6 epsilon naught 3 r square minus r square. Okay. So simply speaking, you can convert this formula. Just remember these two formulas, 1 and 2. If you want to find at center, keep small r is equals to 0. So you'll get 3kq divided by 2r. 3kq divided by 2r. Okay, at the center. So at the center, 3kq divided by 2r. I don't know what formula I wrote there. B at the center is 3kq divided by 2r. This is the formula. Okay. Yeah. So how the curve will look like? How the curve will look like? Listen, my dear friends, the curve will look like this. This is small r. This is potential. Okay. At first, potential is maximum at the center. So that is 3kq divided by 2r maximum, right? After that, it will decrease like this. You can see this formula is what? Downward parabola. Okay. So it will give the downward parabola like this. Okay. After that, this is the point where small r is equal to capital R. After that, inverse relation means rectangular hyperbola. So after that, inverse relation, rectangular hyperbola. So this will be the curve. This will be the curve you need to remember. Okay. So that's all. Remember this curve. Okay. Yeah. So this is showing the potential due to a solid sphere inside and outside. Okay. Yeah. So remember this formula. Don't forget. Now a question that is there in front of you. Okay. So this is the last question for today's class, my dear friends. More questions we'll discuss later. Two concentric spherical shells. Two concentric spherical shells of radius r1 and r2. So there are radius r1 and r2. Okay, and given that r2 is greater than r1, means outer sphere is having radius r2 and inner sphere is having radius r1, are having uniform charge distribution q1 and q2. Okay, so charge on inner sphere is q1, charge on outer sphere is q2. Find the potential at point A. Are you getting? You need to find potential at point A. Means what? Potential at the center. Potential at the center you need to find. Next, at the surface of the smaller sphere. So you need to find at the surface of the smaller sphere, at the surface of the larger sphere, and after that more things are there. So let us solve it. Let us solve it, my dear friends. Let's say this is the outer sphere having charge q2 and radius r2. This is the inner sphere having charge q1 and radius r1. Chal. So at first the point is at the center. So I will say potential at point A means potential at the center. What will be that? What will be that? All of you know. all of you know, if I bring the charge from infinite to the surface of outer sphere, है ना? So I will say potential due to outer sphere plus potential due to inner sphere. So I am bringing the charge Q from infinite, charge capital Q2, है ना? Plus Q1. Okay. So I am bringing the charge from where to where? I am bringing the charge Q2 from infinite to R2. So directly I will write KQ divided by KQ2 divided by R2. This Q2 charge is brought till R2 only. Okay. So I will write this. Now plus due to Q1. So charge is brought from infinite to R1. Are you getting? So I will directly say KQ1 divided by R1. So what is the answer? So answer is what? VA is equals to K is, you can take it common, 1 upon 4 pi epsilon. Also you can write Q1 upon R1 plus Q2 upon R2. Okay. So that's all. This is the answer for this first question, potential at point A. Right? That's all. So I hope first answer all of you got, right? So potential at point A will be equal to KQ1 upon R1 plus KQ2 upon R2. Why? Because it is at the center of both the shells. Okay. So simply speaking, Q2 charge is brought from infinite to R2 and Q1 charge is brought from infinite to R1. Okay. So that's why we are writing KQ by R1 plus KQ by R2. Right. Next, you need to find the second potential at the smaller surface. So, my dear friends, smaller surface means at point A we need to find. Okay. So, simply speaking, if you talk about this potential due to this charge Q2, so I will say at any point, potential will be KQ2 by R2. Why? Because charge is brought from infinite to surface only, and outer surface. Okay. So, directly write VB, that will be equal to V1 plus V2. Okay. So I will write V1. V1 means charge is brought from infinite to the smaller surface. So I will say KQ1 upon R1. No doubt. Okay. Now for outer surface, the charge is brought from infinite to the outer surface. So KQ2 divided by R2. Okay. And this potential will be also inside throughout the space, right? Yeah. So the same formula we are getting for the inner sphere surface. Okay. Yeah. Simply na yaar, for the inner sphere we will get KQ by R1. Okay. KQ1 by R1. And due to outer we will get KQ2 by R2. Why? Because Q2 is brought from infinite to R2 only. It is not coming inside. Okay. Yes. Next, I will talk about potential at point C, means at the surface of larger sphere. So larger sphere is there. So you can see charge Q1 is brought from infinite to inside, but I cannot write that because I need to find just at this point. So I know the charge Q2 is brought from infinite to this point and charge Q1 is also brought from infinite to this point, right? uh, that much work only we need to use, not inside work. Are you getting? Means it is coming to inside the sphere that we don't need to use. Okay. So simply speaking, KQ1 upon R2 plus KQ2 upon R2. So this is the general formula. So you are getting KQ1 plus Q2 upon R2. Why only R2? Because charge is coming from infinite to outer surface. Okay. So whenever, doesn't matter how many spheres are there, charge, if they will ask potential at the outermost surface, always you need to do like this only. Just bring the charge from infinite to all charge from infinite to outermost surface only. You'll get the answer like this. Okay. That's all. So this is the potential at point C. So now the last question, potential at any point less than equal to R1 means that is inside the shell. Are you getting? Right? Yeah. So I am erasing this all, my dear friends. So in first question, they are saying that this is the outer sphere, this is the inner sphere, this is R1 and this is R2. This is charge Q1, this is charge Q2. Okay. So in third question, first part they ask R is less than equal to R1 means any point that is here. So this small r is here. So what you will write? What you will write here? So directly you will see this is the innermost point. So charge is brought from infinite to R2 and from infinite to R1. So directly you will say V at this point will be KQ1 upon R1 plus KQ2 upon R2. Because Q1 is brought till R1 and Q2 is brought till R2 only. So I have to write like this. Next, you need to write second R1. Yeah, this is R2 and sorry, this is R and R2, means the charge is brought from infinite to this point. So let's say this is point P, so I am writing here P. Let's say this is point Q, so I am writing here Q point. So at Q point, what will be that? Charge is brought from where to where? Charge is brought from infinite to this point. So this point is inside the outer sphere, है ना? Inside the outer sphere, but outside the inner sphere. So I'll write that is V1 plus V2. Okay, V1 will be what? KQ1, and point is outside. So for outside point KQ divided by distance, है ना? From the center. So KQ1 divided by small r. Due to outer sphere, that will be KQ2 divided by R2. Why? Because this point is inside the outer sphere. So you will get KQ2 divided by R2. Okay, that's all clear. Last, R is sorry, in the first question, it's okay. Last question, R is greater than equal to R2. Okay, R is greater than equal to R2 means point is just outside. So let's say this is the point R. So you will see potential at point R, this both the points are outside. Sorry, this point is outside both the shells. So you'll write KQ1 upon small r plus KQ2 upon small r. Okay, that's all. So this is the answer. So I hope all of you got the all answers right. That's all. This is the solution of this question. If you did not understand, please go through it once again. Okay. Simply speaking, if point is outside, you need to remember the formula KQ divided by small r. Okay. Yeah. So that's all for today, my dear friends. I would like to say thank you to all my dear friends. Okay. I hope all of you get it right. If you like this lecture, please give a like, right? Please give a like to subscribe our channel if you did not subscribe yet. Please use my code RAHULT Rahul T and get the 10% discount on Unacademy subscription. So my dear friends, simply speaking, we have two type of subscriptions for you. We have two types of subscription for you. First subscription is plus subscription. Second is iconic subscription, right? Definitely, iconic subscription is very very important, or we will say very very useful for iconic. For iconic subscription, you need to pay how much? For 1 year. For 1 year, you need to pay 40,400 sorry 40,500 rupees if you use my code Rahul D. If you use my code Rahul D, and you need to pay 54,900 rupees if you use my code Rahul D. Okay, yeah. And all of you know about plus subscription, right? 1 year subscription is available for 1 year subscription is available for 27,000 rupees if you use my code Rahul D. So please do subscribe and please get the Unacademy subscription. Okay, right? Here you will get India's top educators, right? And it will also decide how longer I will be available for you, right? So thank you, my dear friends. Definitely I'm always available here to help you. Okay, yeah. So thank you, my dear friends, right? Bye bye for today. So this was a premiere lecture. Okay, and I hope all of you got it right. So thank you, bye bye, good night.